And we are live once again. Welcome to day 4 of HaasTec 2020.
Day 4, Thursday,
right?
yeah. It feels like day 4.
It does. So
in a good way.
Early out here on the West Coast, 7 a.m. Pacific, 10 a.m. Eastern. Want to thank you as always for joining us.
Thank you so much for joining us. As we keep saying every day, we got 2 different times that we start these things. Today we're starting early. Tomorrow, last day, we'll be starting at 10 a.m. again, and then again at noon. And 9 a.m. Why do I always mess that up? I got to mess that up, right?
All
right, we'll start at 9 tomorrow, 9 a.m., and then again at noon. But today we're over here in the products area.
Yep.
Got a couple of really big machines to look at. We'll get to that in a minute.
Yep. So we're 7 a.m. right now, and at 10 a.m.
That's right.
These times all
That's
messed
right.
up.
No, see, I'm messing you up now.
10 a.m. we'll be back in the demo room up at the front of the building, and we're going to do an episode of Haas Tooling. So,
that's right. Definitely stick around to see that.
Yep. So want to mention today, because I keep forgetting to mention it. Marcus Imes is monitoring chat. He's doing a killer job on that. He's even, I saw him answering.
Yeah, he's answering in other languages, in Russian, yeah. So, yeah, Marcus is all over that.
So if you have any questions, comments, anything you want to know, hit Marcus up on the chat, and he'll answer you right away.
That's right.
Okay, so we want to mention the promo that we're having. We got to mention this every day.
Got to mention it every day. So don't forget, you can get an extra 5% off your order right now, as long as you do that by tomorrow. Tomorrow, I suppose at midnight, I guess, right?
Yeah.
So tomorrow the 18th, get your order in, and you'll get an additional 5% off.
Right. So it's called the Unlock the Savings promo. If you go to HaasCNC.com, go to the home page, you'll see it there, and once you click in, you'll see the discounts on all the different machines.
That's right, and Brian always says you don't even have to talk to anyone. You can, of course, call your HFO and talk to someone face-to-face if you're interested in doing it that way, but you can also just click the build and price button on the website, and it'll take you to configure your machine.
Right.
And you'll see the discounts there.
Absolutely. So here's what we're going to do this morning. We decided to open with a little different intro instead of Andrew and I on camera. You saw the inside of a UMC 1600H. But before we get to this is actually going to be the second machine. Yep.
I think it's time to walk over now.
Yep.
So I'm going to head over here.
Andrew's going to head over.
Follow me, Sal. All right, so we're headed over to the UMC 1500 Duo. I'm sitting here again with Milton Ramirez.
Morning, Andrew.
Another product specialist. It's all product specialists and Brian and I during the week here. So now we looked at this machine on the first demo day live. Brian and John looked at this machine, and we thought we'd do another lap with it because it's a really interesting machine. It's got a lot of capabilities, and it really gives you a lot of possibilities.
Exactly. Yeah, this is one of my favorite machines since its inception. What's really great about this machine is basically it is still a UMC 750, but it has an addition. It has the work envelope and pretty much the same table and travels of a VF2 YT.
Right.
So a VF2 YT, as I was saying earlier, has a 30 inches of travel on X, and UMC 750 also has 30 inches of travel. So this machine
has
60.
60 inches of travel. Yeah,
So basically, they
put them side by side, basically.
They added both travels of X, and now you have 2 work areas that are definitely, lots of space, lots of room to do your 3-axis work or 5-axis work. So
right. You can have back-to-back 5-axis and 3-axis jobs.
Yeah. And what's really cool about it, it retains all the 5-axis capabilities, right? You have still your C-axis platter, your B-axis tilt, and all the good things that we implemented with the redesign of the UMCs as well.
Right. Yeah, new spindle head, new...
external coolant tanks, the door is different, and we'll talk about a little bit more about all that good stuff.
So another cool thing about the travel is, kind of maybe one of the hidden benefits, I suppose, is that you also have all of that X travel, and both of these are at the same height.
Yeah,
if you do need to fixture a really long part, you've got that additional capability.
That's a great point, because it does give you that capacity to hold a long part onto 2 surfaces, right? Because as you said, the platter and the table are at the exact same height.
Right.
And if somebody's curious and would like to know, if you tilt the platter at 90 degrees, then the center of rotation is 2 inches above the table.
Okay.
So just for throwing that out there. Okay.
So now this is an SS machine. This is not an SS. Okay, so this has the standard spindle.
This is 8100 RPM, 40 taper. It does have the option of upgrading to 10,000, 12,000, even 15,000.
Right.
You can get HSK taper if you'd like as well.
Oh,
but
40 taper or HSK.
yeah, but
right.
HSK only comes in 12 or 15,000 RPM, right? If this was an SS machine, then obviously you get a 12,000 RPM standard spindle.
Right.
You get the faster rapids, the faster tool change, and high-speed machining is standard on the control as well.
Right.
Yep.
Cool.
Okay, so
now this machine, let me peek around. So this does have the 50 pocket tool changer on
yeah.
it. So standard is 30 pockets, of course, but you can, if you need those extra tools, you've got that option.
Yeah, they do come in handy when you're, especially when you're doing two types of work. I mean,
right.
At any given time, you can stop doing a 5-axis job that you're probably running, and now you have a hot, 3-axis job that you want to run on multiple vices. You can do that right away, and that's why you would want to have a lot of tools.
Yeah, you can make that argument either way, right? If you're running something consistently on either table, you've got the other one at your disposal to run something that comes up.
Yeah, exactly. Yeah, you can't
and
compare.
You can even, you can easily run 2 3-axis jobs as well.
Yeah, exactly.
No reason you couldn't do that.
Yeah, that's one of the really cool things about this machine as well, because the trunnion. Let me show you something here. I'm going to rotate or tilt the axis. By the way, it has 120 degrees to the positive direction, which is that one right there, and it has negative 35 to the other side. But what I want to show you here on the tilt axis is that there's also a flat surface where you can bolt on a smaller, maybe 5-inch vise. There's a half 13 bolts threaded holes here for a 4-inch or 5-inch separation, so that you can put a vise here. Basically, what most people do with this vise here is just machine the dovetails when you're going to hold something for 5-axis work, so you can reach all 4 sides and the top of that part. Dovetail is the usual way to go. So this works as a preparation vise for your 5-axis work.
You really have these 3 different surfaces to take care of different operations, kind of depending on how you want to do it.
That's right. It's just a lot of versatility. That's what's cool.
Right. You might prep your dovetail there, do your 5-axis work here, and do your cleanup on the machine the dovetail off here or something along those lines.
Exactly. Yeah.
Right.
So that's your negative 35 degrees. I'll put this back in a certain direction. So one other thing that comes standard with this machine, since it's such a long travel, or you're going to do tool changes and things like that, is that it has a second home button that I want to demonstrate. But before we do that, maybe do we want to talk a little bit about the differences on the exterior of the machine?
Yeah, sure. Let's do it.
Okay. So because of the redesign of the UMC 750s, one of the best things they did was they put the doors on the inside of this machine.
Right.
So
no more
now,
dumping a big pile of chips out on the floor anymore.
Yeah, exactly. And it made the doors smaller, they're lighter, they're easier to close, right? The first thing I want to show you is that you can open the door just halfway, right? You don't have to go all the way.
Right, it's got this cool 2-stage door.
Yeah, in case you're just working here, you're just doing 5-axis work, you're changing out your part over here, you can reach your control. You don't have to open it all the way. So it's really simple to just go close it.
Right, so if you're on the UMC table, you're probably just using that first segment.
Exactly, but if you're doing full work, then you're going to go all the way and open it like that.
And it's pretty easy to open,
super
surprisingly.
Light. Yeah, it's super light,
really
really easy. Chips don't get in the rails or anything, so it stays smooth the whole time. So
then some of the other changes, like in terms of control position, this stuff here.
Exactly, because of that door inside and smaller, area there that's taken by the door, then we were able to put the control on the front of the machine. It used to be on the side, so now it's in the front, more convenient, closer. You can actually work and get in there closer and see what you're doing. Plus, we have room now to put all your convenience
features,
right?
That's right.
You always want to put tools up there.
You have a place to put your tools, a place to put your
tooling, wrenches like we have here, and the convenience of this the cabinet back here too, where you can store the operator's manual or whatever other important documentation that you might have.
Right.
External 55-gallon coolant tank is standard, which is pretty much the standard coolant tank for most
You're probably going to get to
machines.
this, but also moving the control around to the front gave us more possibilities on the side in terms of where the side window is at.
Yeah,
what we're doing with that.
And towards the end, I guess we'll go around, because I would like to get a shot of the vices and all that from the window. Okay. But yeah, you do have that window, that opening there, and in case somebody wants to add third party or Haas, some Haas type of automation, you can, and that gave us that possibility.
That's right. You want to put a robot there to load that,
put a robot
a fixture there,
a pallet pool, or an APL. whatever it may be, right? I don't know if it's available for this machine, but on the UMC family, that gave us the opportunity.
Right, we saw that.
To
Yeah,
do
we saw that yesterday, actually.
Exactly. Yeah. So yeah, those are some of the good points. Something else that this machine has standard is it has the templates, the VPS templates. It comes standard with whips. Obviously, it comes in really handy for all your 3D work, but it's most useful for your 5-axis stuff as well. When you first get the machine, I know a lot of customers that at least once a week, they want to double check their MRZP values. So we do have templates here that customers can use.
Right, we talked a lot yesterday with Marcus about setting an MRZP, and all that stuff comes standard, all the tooling ball and everything to allow you to set that. Standard, and you've got the templates that walk you through that process. Exactly,
simple data to enter here on the templates, and all that process is automated and saved in the settings, and you're ready to go with accuracy.
Right, right.
Yep, so what else do we have here to
so
mention?
Also, I think one of the other things cool to mention that's come standard with this is DWO and TCPC.
Yeah, it's definitely
that's
standard
an option on some machines, but on these, it's a standard, and it's really indispensable in terms of making programming easier.
Yes, dynamic work offsets and tool control point compensation.
That's what it stands for,
exactly,
if you haven't heard us say that.
Yep, so that comes standard on the control as well, okay? So let me do a tool change, because I want to show you what the second home button does, okay?
Right.
So for safety reasons, we're going to close this here.
Yeah, well, won't let you do that without doing that.
So if I wanted now to maybe take that tool out, replace it, do something with it, then it's kind of far away. I'd have to open the door the whole way.
In there,
But the machine comes standard with the second home button. So what I can do is I can program the position that it's going to right now. So let me just press that button.
All right, so now it's totally accessible.
But the second home button does, it conveniently brings the spindle to wherever I want it to go.
Right, maybe you even want it here if you're putting your tools here or something.
If that's what you want. If you're maybe changing the tools over on that on the convenience shelf there, you could put it there. It's programmable on the user settings here up in the settings page, right? You go to the user positions, and that's where you have your second home position. You can program it for X, for Y, Z, and also even the rotation. In case it's up at a certain angle, you can make sure that this is programmed at 0, so that when your tool comes over, the platter is going to go flat, right, and get out of the way. I did have it at 0, so it didn't move because it was already there. But that's just another safety feature of that button. Okay,
cool.
So
do you want to talk a little bit about the fixture or the work holding we have in here for just a second?
Sure.
Sal, do you want to maybe brush it, blow it off?
Come over through the
we'll get out of their way, Sal. You can come in here a little closer and just take a look. Now, all of this work holding right now is not on the website yet, but it's coming soon. We're also going to be taking a look at, I think we'll be taking a look at some of this stuff, not tomorrow, later today, over in the demo room when we switch locations.
That's right. So those are the Haas vices. I believe those are 6-inch vices there. And we do have the smaller versions, larger versions of these same vices. And I'm sure you guys will talk about that later today, but all the work holding that's available through the Haas, right? And this,
and then over to the right,
on the platter here, we have a riser and we have a self-centering manual vice as well. Those are two different options. I mean, they don't come as a package, but you can get them separately. All the Haas work holding will be plug and play basically. They'll all fit, they'll all match. And we'll just let that, they'll talk about you guys. You guys will talk about that later.
Yeah,
right? Yeah.
Brian will talk about that.
Brian will talk, and John.
I don't know that spiel. So, anything else we want to mention here? Or we?
Basically, I think the major points, the major things are features of the machine. I think we already mentioned.
Okay, cool. In that case, I want to call John Nelson on here for a second. We recorded a demo for this video already, and hey, here's John Nelson. So John Nelson's going to talk us. You're going to talk us through the demo in a minute here, but you want to do kind of a little preamble to it.
Yeah, so I just wanted to mention that when we first came out with the UMC 1500 Duo, for the first demo day, which I believe was June, we wanted a video that highlighted all Haas tooling. So the 2-axis side of this, which is a new demo created at that time, all uses Haas tooling. And then we took advantage of Mark Terryberry's throttle body demo from several years ago to do the 5-axis because it's such a killer demo.
Yeah.
So that's what we've got on the video, and we're gonna start.
Cool, sounds good. John's gonna run around here and try not to trip on any cables. Join Frank over the decks there. So one thing to remember during the demo, they wanted me to say this, is that we purposely turned the coolant flow level down in this video. So if you see that it looks like it's running kind of lean, it is on purpose. You're trying to strike that balance between being able to see the part actually getting cut and then
not
blasting the cameras
up all the tools either.
Yeah, but also not gall up the tools at the same time.
Exactly. Yeah.
So the 3-axis side of this demo was actually inspired by an image I found on the internet, and it ended up turning out really, really well. The first tool that we're going to see come in here is going to face the top. This is a 2.5-inch Haas face mill with octagon-shaped inserts, and that thing's running at 6,040 RPM, 152 inches a minute, and 100 thousandths deep. Next, we're going to demonstrate tool center point control. We'll see as this tool moves over to the corner of this part, it follows the rectangle shape of that block, and all we did is add rotary moves to that position, and you can see that the tool actually stays stationary with regard to the edge point of that workpiece. Okay, so the roughing tool on the throttle body here is a 40 millimeter or 1.575 inch 6-flute face mill that's taken 1/4 of an inch deep. It's really a ripping cutter, and we'll see it several more times in the video here. This is a 3/4 inch Haas 3-fluter that's roughing at 15,000 RPM, 360 inches a minute. We're taking a 7.5 thou chip load with this cutter, and man, that thing really removes a lot of material in a short period of time. Now we're back to our 40 millimeter, this is a 20 millimeter 3-fluter that's running at the same speed as that 3/4, and we're doing the work on the 5-axis side of the machine now. This is that 40 millimeter end mill that's taken 250 thousandths depth of cut. Really impressive cutter. I do want to mention here, you may notice that these tools are traveling in a straight line from the workpiece over to the tool changer. I'll show you that in a second. This is a 1/2 inch TSC end mill, plunging, cutting 2 inches deep. That's 4 times diameter deep. Back to the stationary table, we'll be pocketing with the Haas 1/2 inch 3-flute end mill, running again at 15,000 RPM. That's 180 inches a minute and 600 thousandths depth of cut. Go back to what I mentioned before. You'll notice when we do tool changes on this machine, the cutters are making a straight line move from the workpiece up to the tool change position, and that's because I utilized setting 247, which is XYZ simultaneous tool change. Now most machines ship with this off, all machines ship with this off, but you can turn it on if you want, and this is really advantageous on machines where the spindle travels in more than just the Z-axis to tool change position. So if this setting is on, it will go straight up in Z and then move X and Y over to the tool changer. If this setting is off, the tool will travel in a straight line from wherever it's programmed to do a tool change up to tool change position. So it can save you a lot of cycle time on tool changes. Let's see, we're back over to the rotary portion where we're drilling 1/4 inch diameter holes. There's our 40 millimeter insert drill. That's a Haas insert drill, drilling all the way through that 3-inch piece of aluminum in a really short time. Very impressive cutters. Back to our 2.5-inch octagon face mill there. Back over on the Rotary, our 40mm 6-fluter. Again, 7,800 RPM, 130 inches a minute. That's taking 8 millimeters deep, or 315 thousandths. We'll go back over to the stationary table here in just a second. Oh, my apologies. Back over to the stationary table now. That's the 1/2-inch, 1/4-inch, and 3/8-inch chamfer tools are all putting the finishing touches on the part here. We are drilling a couple holes in it there as well. Let's see now, the chamfer tools cutting on the Rotary side. That part is finished, so it's a little dump cycle to get rid of the coolant. We're going to flip that part over, take care of the second side. Same face path that we saw in the beginning. There's our 20mm end mill roughing the profile. This is a really cool helical OD cut, and then that same cutter opening up the inside diameter. You can tell that's a nice thin wall. There's our finish end mill, finishing the ID, and then a little chamfer on the ID. Now that part is finished. We're bringing the drill with TSC coolant on over to blow the chips out from underneath the vise. And there it is. Our demo is complete.
All right, thanks, John, for walking us through the demo. So before we move over to the other guys in a second here, you wanted to say a couple more things about the machine, right?
The one last thing about the footprint, because it is a machine that has very long travels, but we want to give some comparison for customers that are maybe familiar with other Haas machines. So in terms of length, the machine is, as we had here, 3 inches shorter than a VF5. So it's comparable to VF5 in length. Now in depth, it's 13 inches deeper than a VF6.
Right.
So I think that puts you
so
around.
You're kind of in the large VF spectrum, but you've got all this work envelope, and you've got 2 different places you can do it.
So it's not really a very large footprint for what it is. Right. But it's something that's easy
and it gives you the capability to do 5-axis and 3-axis work back to back.
Exactly.
Very easily.
Yeah.
Cool. Thanks, Milton, for walking through this with us. We're going to throw it over to John and Brian over on the UMC 1600H.
All right, thanks Andrew and Milton. And we're about 10 feet away. I could hear everything you said. Cool demo, and we're back here with John Nelson. We're on the UMC 1600H. Now, this is a 50 taper machine. It's 3+2 or full 5-axis standard,
for sure.
And it's based on our EC1600 ZT model. So if you're familiar with our product line, you'll look at this and say that looks a lot like an EC1600. That's because it is. So what kind of industries would be interested in a machine like this?
Certainly anything that's doing any industry that needs 5-axis work on large, heavy parts, right? So oil and gas for sure. We've got several oil customers that use a very similar setup to this, and that's sort of what spurred the design of this machine. Also heavy industry, right? Forklifts, large trucks, anything like that.
Sure.
Large parts.
Large parts that need either 3+2 or 5-axis machining. Okay, so let's talk real quick. We'll just go through a few of the specs real quickly here. The travels are 64 in X, 50 in Y, and 40 inches in Z. So let's talk about the spindle, because that's really the highlight of this machine is the 50 taper spindle.
So the 50 taper, 7,500 RPM, 2-speed gearbox, 50 taper spindle. It's also got an optional 7,500 high horsepower, 60 horsepower spindle, or a 10,000 RPM, 60 horsepower spindle. So you can go either way with those spindles. But that 50 taper spindle really is the workhorse of Haas machines that are, you know, doing a lot of heavy work around the world, really.
Yeah. So if you guys were with us, I think it was 2 days ago when Marcus and Andrew were on the EC500 50 taper and saw the heavy slotting that we were doing, that's a perfect example of the type of work that you can do on a Haas 50 taper.
Yeah, exactly. And it's the same spindle. As that machine.
Exactly. So let's talk tool changer real quick. Standard with a 30 pocket.
Yes, and optional 50, and also optional 120 pocket chain style tool changer, which is new for us.
Yep,
for sure.
That's a new addition for us. Yeah. Let's see.
This machine, sorry to interrupt you, this machine has the 50. I'm not sure if you want to walk around and show it.
We can show it at the end, I think, once we get Sal around there. So I think, Sal, you want to come in here? Because we're going to talk about these rotaries, which is really the highlight of this machine. So 630 millimeter diameter rotary on the 5th axis.
Yeah, so the
I'm going to let you talk it through.
Is the 630 millimeter diameter, and the through bore on that rotary is 10.125 inches, right? The rotary itself comes with, and if we could sort of sweep around here, Sal, and show a little side view, you can see that this rotary has the T-slot table, right? That's the standard table that comes with this rotary. It's 8 T-slots at 45 degrees around that, radial T-slots around that rotary, but it also has a couple of options available. You can get a drilled and tapped faceplate with circular drilled and tapped hole patterns, and you can find that in the machine layout drawing for more information on that. Or you can get an A1-20 spindle nose if you're always going to use a chuck, either 3-4 jaw chuck, maybe a pneumatic chuck for automatic operation. You can get a spindle nose as the permanent mount to that rotary as well.
Okay, and there's, Frank, if you don't bring the website up yet, but if you can get it ready, we've got some machine features. On the
So
rotary
Sal,
here. So Sal, if you can come in again.
Get a close up in here. So this face, this surface here, and tapped holes here are machined to accept the optional T-slot tables that can bolt right to this. Now they're about as wide as that surface is machined, to give you an idea of how wide that is, and they come out in 2 different lengths, which we have more information on the website, but you can get those, and then those are an additional support for a steady rest, an A-frame support, or maybe even a tailstock.
Right. So 2 different table lengths and multiple different supports.
Yes.
Tailstock, steady rest, etc. Okay. All right, Frank, you got that up on the website? Okay, good. Think you can come back now?
Yeah, so I did want to mention that engineering has tested routing of pneumatic lines, 1/2-inch diameter, OD diameter pneumatic lines, or I guess number 4 size hydraulic lines, 2 of them each, through the rotary configuration, so that you could attach an air chuck or hydraulic chuck to this rotary.
Yep, so nice clean routing up through the center.
Yep.
Okay. Travels, let's talk travels real quick. And maybe when you do this, do you mind grabbing the
sure, I'll grab
jog
the jog handle.
It's a big machine. He'll be back in a minute. Here he is. Okay. So we're going to talk rotary travels.
So let's see here. Sorry.
Oh, we got to go into handle jog mode. So the C-axis
sort of helps when you put it in jog mode first.
Yeah, it does. So the C-axis is full 360 degrees of rotation, right?
C will give you the. Excuse me.
There we go.
Had to wait for the brake to release. C will give you a full 360, basically unlimited rotations on C. And then the B is plus or minus 120. Right now, we are all the way pegged at minus 120. And then I'll head back over towards 0. And then spin it around and you get an idea. So there's where you can route your cables for your hoses for pneumatic. And then you'll see that we have a machine surface on the side of the casting here that you could put a vise. This is a Haas 6-inch vise that bolts right up there that you could do extra work if you needed to. You could use this for something else. If you didn't have big parts to run, you could still run some parts over here. However you wanted to utilize it, but it's machined, it's square, and when this thing's set at minus 90, it'll be facing the spindle.
I'm throwing a curveball at you because we didn't talk about this beforehand, but you mentioned the brake on the rotary.
Yes.
And I wonder if you could talk about that from a programming standpoint.
Oh, yeah, thanks. So let me drop this off.
Hold, please. We'll be right back. Some music.
So, sorry about that.
It's all right.
We didn't rehearse this part, folks. Sorry. The rotary brakes. So there's a command to clamp the 4th axis brake, which is M10, clamp the 5th axis brake, M12. Release the 4th axis brake, M11, release the 5th axis, M13. So those are, a lot of times post-processors will output all of those clamps. But those codes are really unnecessary unless you're going to do a simultaneous toolpath. And here's what I mean by that. When the Haas control sees a command for a rotary axis, it knows automatically that it needs to release the brake to make that move. And when that move is complete, if there's not another rotary axis move on the block right after it, it's going to clamp that brake after the move is complete. You don't have to worry about brakes, turning them on, turning them off. Where you do need to be concerned is if you're getting ready to do a simultaneous 5-axis toolpath where you're going to have a whole bunch of blocks in a row that are going to have rotary moves, but you might have some interspersed in there that don't have a movement on 1 or 2 or 3 blocks.
Right.
Well, your nice smooth rotary axis, nice smooth simultaneous 5-axis motion is going to stop and wait for that brake to clamp because there was no axis move on that block.
That's right.
So that's why you want to use the M code to unclamp the brake at the beginning of your toolpath so that the control doesn't try to clamp or unclamp when it sees a block with or without a rotary move.
And that can have a huge effect on cycle time.
Exactly. That could make your part's going to look terrible. Your cycle time will take forever. So anytime you're doing a simultaneous 5-axis toolpath, unclamp the brakes at the beginning of the toolpath and make sure that you clamp them again at the end, because if you unclamp a brake with an M code, it's going to remain unclamped till the end of time or until you cycle the power on the machine.
Right.
So, or that you reclamp it with the M code. So the only way to clamp it once it's unclamped is clamp it with the M code or cycle the power on the machine.
Okay, good.
Okay.
Thanks for explaining that.
Yeah, no problem, no problem.
Threw that in there. We had talked about it the other day, so.
Yeah.
Okay.
It really does increase cycle time, sorry.
Yeah, you had talked about
M codes,
you had done a program.
you can only have 1 M code on a block.
That's right.
So if you have to release the 4th axis brake, that we have to wait a second and a half or whatever the brake release time is, and then the next block gets executed for the other rotary axis.
And waiting again.
But if you have a block of code, if you're not using the M codes to release the brakes, you have a block of code that has both rotary axis moves on it, they both unclamp at the same time, they both move at the same time, and they both clamp at the same time. And that can save you seconds every time you index, 3 seconds every time you unclamp, move, and reclamp.
Right.
So it's a big deal to not have all of those M11, M13, M10, M12s in your program when you don't need them.
Right. Okay, thanks for explaining that. So brake torque, each of the brakes on this rotary have 4,000 foot-pound of brake torque.
Massive.
Huge amount of brake torque. I think we want to talk about, because there are some tight areas in here depending on the size of your part, and we've been emphasizing this on all our 5-axis machines, that you really need to be familiar with the machine layout drawing.
Yes. Study the machine layout drawing. Because the tool axis is fixed along Z, it's not quite as important on the tilting head as it is on the tilting head machines.
Right.
But still, you need to know your rotary stack up, right? So when I was setting up this demo, I needed to know the thickness of my spacer, the thickness of my chuck, the width of my jaws, and then where my part was before I could tell if I was going to have enough room. And so you really have to have a good idea in your mind when you're trying to figure out, will my part fit, what your actual work holding setup is going to be, and where your part's going to be in space once you get to
and
rotating
you know, we quickly talked about some of the other options like the tables and the steady rests and things like that. If you go to HaasCNC.com and search UMC 1600H, you'll get the machine layout drawing. There's a details tab on there where you can look at all the optional work holding. We didn't do it justice. We kind of glossed over it. But that's where you'll find everything.
We did pass by the weight specification. So you can put 1,500 pounds on this rotary when it's unsupported. And if you have the extension, T-slot table extension in an A-frame or steady rest or something, you can put 3,000 pounds up there.
Okay, 15,000 unsupported.
1,500.
15,000. Wow, added an extra zero in there. That's important.
1,500 unsupported, 3,000 supported.
Okay, great. Let's see. This is now, you talked a little bit about post-processor. I can't speak today.
Yeah, post-processors. So this is essentially a UMC, right? The only difference between this machine programmatically, writing programs for it, and axis orientations, the only difference between this machine and a UMC 1000, for example, is the fact that this machine, the B axis, has plus or minus 120 degrees of travel, whereas it's limited to less than that on the UMC 1000. But as far as posting code, generating code for parts on this machine, the same exact post processor would work fine. Adjusting the travel limits in a post processor is a very minor thing. Most guys can do it themselves, or you can get your post supplier to do it really, really quickly. It's not a big deal. But essentially, it's a UMC. Same orientations of axis and all that.
It's good to know. Okay, let's talk about VPS templates.
Oh yeah. So we created a custom VPS template for this machine, and it essentially runs the same probing cycle code that you would use on any UMC. But the template to begin with is different because the layout of the rotary looks different. And the standard rotary axis calibration tool, you know, the stem with the ball that we supply with all of the rotary products, doesn't fit on this machine because it's so big. So we made a special longer base for that rotary axis calibration tool, so it'll go across that 10-inch diameter hole through the middle, and you can program in the middle. And then there's actually a special thing I want to point out if you're using an older magnetic base tooling ball with a stem on it there. So Frank, if you could bring up the control over here, I want to walk around to the control and go over to the VPS template, down to probing, down to calibration, or sorry, down to custom. And here's the MRZP template to set MRZP on the UMC 1600H. There's our template, so you can see the image there of the rotary axis calibration tool where it's got the straight artifact. And if I have that one, I'm going to bolt it up there and press the S key. But if I have the old magnetic base with an angle on it, I am going to go ahead and press the M key. And then it's going to show me this image. And really what this means is that I have to place that magnetic base at a 45-degree angle, pointing either down or up, and it needs to be on the right side of center line if I'm the operator looking straight at the rotary platter. The red zone, I can't put that mag base anywhere else in the red zone or I won't be able to reach that ball. As the B axis rotates around, that tooling ball will actually be too far away for the probe to actually reach the ball. So it needs to be on the right half, and it needs to be in that 45-degree zone, either on the upper right quadrant or the lower right quadrant. And that's really the difference between the template for setting MRZP on UMC 1600H versus setting MRZP on any of the other UMC models that we have. Okay.
All right. I was standing there trying to listen to you.
Sorry
In case
about
you guys see us kind of trying to get close to each other here, we're actually out in the factory. They're still running the machines over here. We're building machines over here, so it's a little bit loud. So there was one more thing before we go to the demo. We are going to show you a demo, and you're going to talk through it like you did on the Duo. But you wanted to talk about setting 335.
Yeah, so setting 335. I mentioned it the other day when we were over at the VR8.
Yep.
I'll mention it again. Setting 335 is linear rapid mode. It's been in controls, next generation controls, for almost a year now, I think. But I mention it now because very, very soon all machines will be shipping with this setting set to linear XYZ. The setting can be set to 3 different positions. The first is none, the second is linear XYZ, and the third is linear plus rotary. Now, a little bit of history. Since the very beginning, all Haas machines went in a G00 rapid positioning command. Any axes, if there are more than one axis move on that block, both axes would start towards their endpoint at the same time at the same speed. So essentially, it traveled away from the start point at a 45-degree angle until the axis with the shortest distance to travel reached its endpoint. Once that axis reached its endpoint, it would stop, but the axis with the longer distance to travel would keep going. And what you got essentially was a dogleg rapid move. So it was a little less predictable, actually very unpredictable, exactly where that tool was going. Linear rapid mode, what we do is we slow the speed of the axis with the shorter distance to travel, and the axis with the longest distance to travel goes at full speed. So it doesn't take any longer to get there. It's just that we get there by traveling in a straight line. All the axes start at the same time and end at the same time, giving you a straight line. You can do all 3 axes and get a diagonal move. That's fantastic. So the 3 settings again are none. If you set it to none, it's going to behave like all the Haas machines that we built since the beginning of time. If you set it to linear XYZ, then we are going to, the linear axes are all going to, if they're programmed in the same block, will start at the same time and end at the same time, essentially giving you a straight line move. If you set it to linear plus rotary, which we will set it to on machines that have built-in rotary axes like this one, then all the axes that are on that particular G00 block will start at the same time, end at the same time. And what this does is give you a much more predictable path. It's super important in 5-axis, especially on tilting head 5-axis machines, where the tool is moving around and the workpiece may be moving in some of the axes. So, so it's a much more predictable move, and believe me, if you've been running Haas machines with dogleg rapids forever, and you turn setting 335 linear rapid mode on, you're going to love it. It's going to be a little different at first, but I think you'll really like it. And I wanted to mention it, and also wanted to make everyone aware that it was coming, that machines would be shipping with it set to on in the very near future.
Okay. Do we want to go to the demo?
Yeah, let's do that. Let me run back over here.
John's going to head over there. So Sal, if you want to come around here. And we're gonna go to the demo here shortly, but so John, you want to talk about before Frank starts here? Sorry, I just walked out of frame.
Yeah, so this part is an actual ductile cast iron part that we use in the factory. This is the B-axis gearbox subplate used on EC 400s and 500s. My program doesn't make our actual part because there's no 5-axis tool paths on the actual part that we make, but I was able to use the shape of this casting and the size of this casting to show off this machine and to program some 5-axis moves. The OD of this part is 23.8 inches and the ID is 13.5. That casting is 2.68 inches thick, and we had the machine shop face the backside and rough the bore to clean it up so we could grab it on our on the ID with our manual 25-inch 3-jaw chuck. I used Fusion 360 to program this part. This was the first 5-axis that I had done in Fusion, and I just want to give a little shout out to my buddy Angelo Juris, who I've known for a long time. Really helped me out with pro tips during programming of this. Is very, very cool. Thanks, Angelo. So all of these cutting tools and tool holders in this demo are available on HaasTooling.com. I programmed all the tools right in the middle of the recommended speed and feed range. There's definitely room to go up a little faster or down a little bit slower, but the purpose was to show that, hey, if you start right in the middle of the range, you're going to get good parts right out of the gate. You don't have to think about anything, and there is room to optimize. So we are looking at, this is a 2.5-inch length of cut, 3/4-inch 5-fluter that's doing a swarf tool path around that angled surface. We're going to come back over and put some chamfers on it. I will ask Frank to restart our demo again. When we get to that point, it'll just be another few seconds here, and I'll talk about some of the cutting tools right from the very beginning of the demo. By the way, excellent edit by my buddy Tyler on this thing. All right, so here we're going again. We're going to get to this first cutter is going to be the, oh, sorry, we're loading the part up there. The first cutter here is a 1-inch 4-flute going around the OD. That thing is cutting, it's cutting, let's see, sorry, it's cutting 400 thousandths per side off of that cut and all the way 1.5 inches deep. Running at 1566 and 35 inches a minute. Our shell mill here, that's an HS6 NP 90-degree shell mill, obviously Haas shell mill. It's 2.5-inch diameter 5-flute. We're running that at 700 surface feet and 10 thou chip load. Each of those cuts is 200 thousandths deep. Love this cutter, cut really great. Ripped that cast iron like it was nothing. You can see the good chips there. Next tool is a 1/2-inch drill. That's actually a TSC drill, but we drilled it dried in this cast iron to show those moves. That's 4,100 RPM, 11 thousandths per revolution. So this tool is a 1/2-inch 5-fluter. Again, programmed right in the middle of the recommended speed and feed range, 410 surface feet and 5 thou and 6/10 chip load. For roughing and finishing pockets here, we're going to get to, now this is a 3/8 inch and we're finishing a swarf tool path. So we're putting a 5-degree angle on the walls of those pockets around those curves. So that's the full 5-axis tool path you're looking at there. Again, a 3/8 inch 5-fluter, 48 inches a minute around there. Now we're back to that 3/4 inch, 2.5-inch length of cut 5-fluter that's finishing that angled surface with a swarf tool path. And then our chamfer tools coming in here, they're running at the max RPM, 7,500, and just to put the finishing touches on our demo. And that's it.
All right, thanks, John. So that's going to wrap up our morning session. We will be back at 10 a.m. Pacific. John, if you want to come
Sure.
back in. This is John Nelson Day, apparently, because John and I are going to be back at 10 a.m. Pacific, 1 Eastern, and we're going to talk Haas tooling.
Love it.
And a lot of the tools that John just talked about and that we showed in the demo, we'll be talking about again at 10 o'clock.
Yep.
And a lot more. What we're going to do with Haas Tooling, we're going to, of course, talk about HaasTooling.com. We have a new thing called the Haas Tooling Buyers Club. We'll talk about that. We're going to show what's on the website now, We're going to show the tools that are coming soon, and then we're going to show some stuff that is
Sneak peek
Sneak
at
peek,
stuff
yep.
that's at least 6 weeks away from,
Yes. Yep.
from arriving.
So join us again in a couple hours. Now, the past days, if you've been watching, we've been running the stream continuously. We need to do something a little different today because we're physically changing locations. So we're going to kill the stream for a few minutes, but if you're a YouTube subscriber, you'll get a notification when we come back on. And if you're on HaasCNC.com, it'll go live as soon as we get over there and get the stream running again. So thank you for joining us, and we'll see you in a couple hours.
Great. Thank you.